Hello, this is a demonstration video for the prototype unit that will be given to ETS for testing of the RegenX coil technology. Right now we have a breakout box coming from the RegenX coil and standard coil, and coming out to banana plugs here for testing the RegenX on DC and AC, and the standard coil here same with DC and AC as well outputs. So this will make ease of testing the different configurations. And right now I'm going to give you a demonstration of the RegenX side being charging for 12 volt batteries that are now connected in series, and the voltage across those batteries is at 51.8 volts at this time, and this will be the current that will be going to the batteries, and you'll be able to see that we'll be charging these batteries with up to about 24 watts. This here is a AC input meter here, and this will be able to display voltage and watts going to the prime mover turning that rotor. And this is the standard coil side here, and it is connected to a single 12 volt battery because it is a high current coil. It doesn't necessarily output very high voltage, so this was the best combination to give you also a 24 watt 25 watt maybe output charging a battery as well. And I've used a big battery because sending 24 watts to a single one of these small what are these 5 amp hour batteries would be a little too much for it. So this one is a deep cycle battery, it can handle it. That's why the battery size is much bigger. And here as well we have a meter displaying the voltage on that battery at this present time, and this will be the current going to the battery. I have a optical tachometer, and I have a sensing strip there, which you see that white piece on the rotor there, and I could get RPM. RPM is going to be very important here because that will show us if our motor is going to be, once we put the battery on load, each one will be able to see if it has an effect back to the prime mover. So I'm going to start the device now, and I'm going to get it to spin to full about 3,400 RPM range, and we should be consuming about 200 watts just it turning that rotor without any loads on it. So we'll do that right now. So now we see we have voltage, AC voltage now going to our prime mover. So I will increase that, get the rotor to spin. Once I've reached a steady state speed, I will drop the voltage just to maintain that RPM. So I'm now dropping the voltage. We're going to stay at about 70 volts. We'll check our RPM. So we are steady at 3,400 RPM. And I can drop it just ever so slightly still. So we're just at the edge there, about 69 volts, just to make sure we don't have any extra torque stored into the shaft there. And now I'll display the amount of watts. So we are consuming 184 watts, 86 watts in this condition. There is no load yet on the coil, and we'll once more check our RPM. So we're still at 3,442 RPM. And now I'll go ahead and connect the Regen X coils. So now we're delivering 0.4 amps to our batteries, and as you can see, the batteries are charging very quickly. And if we look at our wattage input, it has not increased. As a matter of fact, it has decreased slightly. So we have a little bit of acceleration happening. If we take an RPM reading, we're at the identical RPM, but there's been a little bit of relief on the motor. So we have not decreased in RPM, and we have not necessarily increased in input power. There's a little bit of fluctuation because of the grid voltage fluctuation. And our batteries are constantly being charged at about 0.4 amps. So here, if you do the math, this should equate to about 24 watts being delivered now. So take note here, 180 watts, and our RPM is maintained, and we are delivering 24 watts, to our battery bank. Now I will disconnect the Regen X coil, and as you can see, we're still 184 watts to our prime mover, and nothing is being delivered here, and nothing is being delivered here. And now we will connect our standard coil, high current coil. And now that is connected. We are charging our battery and delivering about 2 amps at 14 volts at this time. And this will keep climbing. And we'll check our RPM. So our RPM has dropped slightly. So there is an effect back to the prime mover. And there is our voltage on the battery. So we can call this, it's going to reach 15 volts pretty soon at 1.8 amps probably, around that area. So we're looking at about 25, 26 watts here. So about the equivalent to here. But there's the difference now. We are paying for all those watts right here, because without that standard coil on there, we were at 182 watts. So we've increased by close to about 27 watts to deliver about 24 watts. So here we are at 15 volts at 1.8 amps. Check our RPM one more time. So 3,400 RPM is what we have. I will disconnect that coil. We will go back here and see our watts dropping back to its original range. We're 182 watts about. Nothing is being delivered to our battery anymore. We're no longer connected. And I will give you an RPM reading. So we're now back at 3,000. Sorry about the fluctuation there. 2,448.45. So we're back to our idling RPM and our idling watts. So that concludes this demonstration. Thanks for watching. Bye now.